let's just briefly recap the cosine rule. The cosine rule requires 3 sides and 1 angle, doesn't it? Okay, so if you think about the cosine rule, okay, that's a squared equals b squared plus c squared. If you've been absent because you've been away and stuff like that, all of this has been videoed. So it's all on Conlon. Okay, just go and look at it. 2bc cosine a. Now if you just look at that, in order to find one side, you need the other 2 and 1 angle. So the cosine rule uses 3 sides and 1 angle. Yeah? And the reverse cosine rule, cosine A equals b squared plus c squared minus a squared divided by 2bc. Okay? Again, uses 3 sides and 1 angle.
Do we get that, the
yes.
angle rule?
Yes.
Okay, so
yeah.
you didn't know it.
No. Okay? And then obviously remember that when you do this, what you'll end up with is cos A equals 0 point something or other. Alright? Now it's possible that it's negative 0 point something or other, but it can't be 1 point something or other. Okay? And then what you'd have to do is to do cos to the minus 1 of whatever of 0 point whatever. Okay? Gives you an angle. So a brief recap there. Okay? Now the sine rule doesn't use 3 sides and 1 angle. It uses 2 sides and 2 angles. Alright, and that's the context of it. So just to show it up to you, here's how it works. That's big A, that's big B, that's big C. I'm assuming by now you're well familiar with this concept. Okay, and the rule says this: A divided by sine A. So in other words, that one divided by the sine of that angle will be exactly the same answer as B divided by sine B, which will be exactly the same answer as C divided by sine C. Now I know I've used all 3, but you choose which 2 you like. It's up to you. Okay? Now, I'm not going to go through the proof of this, but if you upside down them all, if you inverted them all, then sine A divided by A equals sine B divided by B equals sine C divided by C. So you can switch it all upside down if you want. So there are 2 sine rules, but we're going to do them both at the same time. Okay? So carrying on then. This is actually how it's going to work. If I tell you that that's 40 degrees, okay, I tell you that's 17, I tell you that's 60 degrees, and I want to know x there, what we do is we're going to call that A, we're going to call that B, so we're going to call that little a, and we're going to call that little b, okay, and we're just going to write down our rule every time, okay. I expect you to write down the rule you're using every time. Now on this particular occasion, I've not bothered to write the C over sine C thing. Why? Because I'm not using C in any way, so there's no need to. You only ever need to do 2 of them.
Yeah.
Okay, but you need to be aware of the fact that all 3 work. So now at this point, it's just a case of substituting in. So I've got 17 over sine 40 equals x over sine 60. And it's a really obvious piece of maths now to say, right, so 17 times by sine 60 divided by sine 40 equals x. And you bang it into your calculator and away you go. Alright? So that's basically the sine rule. All you've got to do. Now the only variation on that will be the reverse sine rule, which looks like this. Here's your triangle. Okay, that's 70 degrees. That's theta. That's 40. That's 12. Bit of common sense, please. Is theta going to be bigger or smaller than 70? Smaller. That's because this is 40, this is 12. This is smaller than that, so this angle is going to be smaller than that one. Just think about the concept of a line at the end of an angle. Look, when you make the angle smaller, look at the line. The line gets smaller, doesn't it? Obviously, when this angle gets smaller, that line gets smaller. When this angle gets bigger, that line gets bigger. Hello? Yeah?
Yeah.
Makes sense, doesn't it? Okay, now there are some exceptions to that rule, and I'll show you that later on, alright? But Use a bit of common sense, please. Also, this is an acute angle, isn't it? So it's got to be less than 90. Right. So now what we're going to do is I want to find an angle. Now because I want to find an angle, let's call that one A, let's call that B, let's call that C, which means that that's little A and that's little C. So this time, which two angles am I using? A and C, yeah?
Yeah.
So I'm going to write down my sine rule like this. Sine A over A equals sine C over C. Now because I want to find the angle, I've put the angle on the top. You don't actually have to, but it's a lot easier.
Yeah.
Okay? So at this point, all we do now, having written down our rule, we just wallop the numbers in again. So we can now write sine theta divided by 12 equals sine 70 divided by 40. Make my 70 look like a 70. Okay? A really simple piece of maths. Sine theta equals sine 70 times by 12 divided by 40. Okay, that's going to give you 0 point something or other. And then you're going to go shift sine of 0 point whatever the heck it was equals, and that will give you your angle. That's how you do it. Okay? Here's the big trap. Okay, here it comes. I did speak to you about the ambiguous case. I'll do one more of those. I know I'm going quite fast, but you can always watch the video again. This angle here is 20. This side here is 50. This side here is 12. This angle is, yes, this side is 12. Sorry, big one. And I want to know, and I'm going to call this one alpha. Okay? So, exactly the same as we did before. Let's call this one A and this one B this time. So that's little b, that's little a. Yeah. So all we're going to do is exactly the same as before. Sine A over A equals sine B over B, which gives us sine alpha over 50 equals sine 20 over 12. So sine alpha equals sine 20 over 12 times 50. I prefer to do it that way, so the whole thing's on the top. Makes my life a little bit safer. Okay, and now what I'm going to get is that sine alpha equals 0 point something or other. You've got to have 0 point something or other, otherwise it doesn't work. Okay, and then you go on your calculator, sine to the minus 1, that's shift sine, 0 point whatever the heck it was, and you'll get the wrong answer. Okay, why will you get the wrong answer? Because your calculator will give you an acute answer. Okay, if I could borrow somebody's calculator, please, a graphics one, please. Oh, look at that. Marvellous. So what I'm going to do before I start, I'm going to go shift setup, make sure it's in degrees, like that. There it is, degrees. Okay, that's all good. So what I'm going to do is type in my calculator all my numbers. So I've got sine 20 times by 50, okay, divided by 12, and I'm suspicious because I've got 1 point something or other. What's gone on there? Let's do it the other way around. Let's go 50 times by sine 20. Got the same answer. Divided it by 12. Here's this. Yeah. And I go shift sine, answer, and I'll get a maths error. Why has this gone wrong? I will tell you. It's impossible to draw this triangle. So my mistake is that I've made up some numbers that don't actually work. You couldn't physically draw a triangle where that was 50 and that was 12, 20 degrees rather, and that was 12, and have it work. So I'm going to cheat now. So for those of you watching the videos, There's the price you pay for making numbers up as you go. I'm now going to change it into 22. So I'm going to change that into 22. I'll change that into 22. Okay? Right? That won't happen in the test. If you've got a... Yeah? But it was nice to know that you could do it either way round. Let's exit. So we'll try again. Cancel that. So sine 20 times by 50 is divided by 22. Gives us 0 point something or other, which is all good. Okay? Now I go shift, sin, answer. And I get 51 degrees. Now, this angle here cannot possibly be 51 degrees, can it? So how big is it really? It's 129 then.
Yeah.
Okay? Does that make sense? Alright, so watch out. If you've got something that's obviously obtuse, your calculator will only ever give you the acute answer. Now just to make you feel a little bit better, okay? Remember we get 0.77777? If I go sin 51.01, I'll get about 0.777, see?
Yeah.
Now if I go sin, what was it, 129? Technically it's 128.09 if you really want to be pedantic. Okay? Now there's a small error there. Why? Because the decimal points don't all match. Okay? But that is pretty good. Right? It is the right answer. You've got to trust on it. Okay? So that's how you do it. So if you get the one with the obtuse angle, just be aware of the fact that your calculator will give you an acute. All you've got to do is find out the 180 minus it. Alright? And you'll be fine. Okay? And I apologise for the mistake there, but that's the way life is sometimes. In the exam, that won't be the mistake. Okay? Cool stuff.